Hi friends, I hope the concept of Varignon's theorem is clear to you. Now we shall see the proof of Varignon's theorem. For that, let me draw a straight line, a horizontal line, and let me draw a vertical line also. And I'm going to mark this as y and x. You may mark it as v and h, vertical, horizontal also. For the time being, I'm going to take it as y and x. Now, consider a force F1. Let me redraw it, sorry. Consider a force F1 and consider another force F2. This is F1. In fact, the magnitude is F1. And over here, the magnitude will be F2. F1, F2. F1 is making an angle theta 1 with the x-axis or the horizontal, and F2 is making an angle theta 2 with the horizontal or the x-axis. Now, let us draw the resultant of these two forces and let the magnitude of the resultant be F, and let it make theta with the x-axis or the horizontal axis. So I hope it's clear to you. F1, F2, two forces, in fact magnitude of two forces, and F is its resultant's magnitude. And now over here I've completed this parallelogram also. F2, F2, F1, F1. I have completed this parallelogram, and I'm now, let me give some notations, some markings. A, B, C, and D. So AB is a force of magnitude F1, AC is another force of magnitude F2, each making theta 1 and theta 2 with respect to the horizontal or the x-axis, and AD is the resultant of F1 and F2, and the magnitude of the resultant will be F. Okay, so I hope that much is clear to you. Okay, now over here I'm going to mark a point, and I'm going to mark it as O. Now this O will be our moment center, and we will be taking moment of F1, F2 and F about this moment center. So O will be our moment center. And as we have discussed in our theory classes, the magnitude of moment will be equal to force multiplied by the perpendicular distance between line of action and the moment center. So this will be the line of action of F2, this will be the line of action of F1, and this will be the line of action of F. Okay, now let me draw the perpendicular distances between the moment center and line of action of each force. So let's do that. I'm going to draw the perpendicular distances. So these are all the perpendicular distances from the line of action of each force, F1, F2 and the resultant F respectively. And let me mark the distances as D1 for F1, D2 for F2 and D for F. Let's mark it here to avoid confusion. So D for F. So D1, D and D2 represents the perpendicular distance from the line of action of each forces towards the moment center. So the moment of force AC about O will be F2 times D2, and the moment of the force AB having magnitude F1 about O will be F1 times D1. So D1 will be the arm of force, or lever arm, or moment arm. That will be the perpendicular distance. Now friends, if you look over here, you can see that I have drawn the force with F1 magnitude and F2 magnitude over here with the respective perpendicular distances from moment center, and also I have marked the angle that the forces with magnitude F1 and F2 makes with the horizontal or the x-axis, theta 1, theta 2. Now let us see what will be the angle over here. The angle over here will be 90 minus theta, because this is a right angle. Similarly over here it will be 90 minus theta 2. Why? Because here also it's a 90 degree. Now as we know, the D1 and D2s are the perpendicular distances of the lines of actions from the moment center. So this angle will be 90 and 90. So the angle that D1 makes with the vertical line or the y-axis will be theta 1, and here it will be theta 2. Why? Because this is 90 minus theta, this is 90, so this angle has to be theta 2. Similarly, this is 90 minus theta, this is 90, so this angle has to be theta 1. So considering or taking this logic, we can mark the angle that D2 makes with the vertical line as, as theta 2. The angle that D makes with vertical as theta, and the angle that D1 makes with a vertical line as theta 1. So we have used this logic over here. I hope it is clear to you. If you haven't understood what I have done, just pause the video and rewind it and listen it once again. Okay, we have reached to the final part of the derivation, or in fact the proof. Now if you look over here, you can say that AC and BD are equal. AC, that is the force with magnitude F2, is making an angle theta 2 with the horizontal, and over here BD is same as AC. Therefore it will also be making an angle theta 2 with the horizontal. Here the BH will be a horizontal line, and BD is same as AC, and AC is making an angle theta 2, so this BD will also be making an angle theta 2. Now over here I have made some markings. Let us see, or let us discuss that. E. If you look over here, AE is nothing but the cos component of AD. AD cos theta equal to AE. AE is the cos projection of the force AD, AG is nothing but AB cos theta. So AG is the cos projection or cosine projection of AB, the force with magnitude F1. So let us write AE will be equal to AG plus GE. AG is nothing but AB cos theta 1, AB and its cos component over here, plus what is GE? GE is nothing but BH. BH is nothing but the cosine projection of BD. So let us write that GE is nothing but BH, which is in fact equal to AB cos theta 1 plus BD cos theta 2. Why? BH is nothing but BD cos theta 2, the cosine component of BD. Okay. Now I can write it like this: AB cos theta 1 plus BD is nothing but AC cos theta 2. Why? BD and AC are same because this is a closed parallelogram. AC and BD are the sides of a parallelogram. So I have replaced AC with BD, in fact BD with AC. Therefore AE is equal to AB cos theta 1 plus AC cos theta 2. Now what is AE? AE is nothing but AD cos theta 1. Therefore AB cos theta 1 plus AC cos theta 2. So let us substitute the values of AD, AB and AC over here. AD, AB and AC over here. In fact, this was cos theta, not cos theta 1. I made a mistake, I'm sorry. It's cos theta, not cos theta 1. So let us give the values of AD, AB and AC over here. AD happens to be F. So F cos theta has to be equal to AB happens to be F1. F1 cos theta 1 plus AC is F2. F2 cos theta 2. Now let us multiply the LHS and RHS with OA, the dimension, the length OA. So I'm going to multiply it and write F OA cos theta is equal to F1 OA cos theta 1 plus F2 OA cos theta 2. So we have reached over here. F OA cos theta 1 equal to F1 OA cos theta 1 plus F2 OA cos theta 2. Now friends, I have redrawn the F1 force. In fact, the force with F1 magnitude again. AB is the force with the magnitude F1. It's making an angle theta 1 with the x-axis or the horizontal, and we have the y-axis over here also. So here it will be theta 1 and here also it will be theta 1. We had already established that. Now look over here, look onto this triangle. In fact, let me draw it clearly. Look onto this triangle. You look onto this triangle with this angle as reference. You can say that OA cos theta 1 is nothing but D1. Here it will be 90 degrees. So OA cos theta 1 will be the D1. Similarly, OA cos theta 2 will be D2 and OA cos theta will be equal to D. We can use this same logic and we can find out that OA cos theta 2 will be D2 and OA cos theta 1 will be D. So what you have to do is that you have to take these individual triangles, these individual right angle triangles. Okay, so taking this concept to our equation, we can write f d is equal to f1 d1 plus f2 d2, f2 d2, and this is the Varignon's theorem. So what does it say? It says that two forces f1 f2 and the resultant f. What does the Varignon's theorem states? The moment made by a force about a point, will be equal to the sum of moments made by the component forces about the same point. Fd is the moment made by this force, in fact the resultant force, and F1 d1 is the moment made by the force with magnitude F1. F2 d2 is the moment made by the force with magnitude F2. So Fd is the moment made by a resultant, F1 d1 is the moment made by its first component, and F2 d2 is the moment made by the second component. This is what the Varignon's theorem states. Now let us look upon to the d1 and d2. What are d1 and d2? These are the perpendicular distances from the moment center towards the line of action of the individual forces. In some cases you will have to draw the line of action to get the perpendicular distance, and in some cases you don't need to draw the line of action. In the case of F1 force, in fact the force with magnitude F1, you don't need to draw the line of action. But in the case of F2, we cannot draw a perpendicular towards the moment center. In that case, what we have done is that we have drawn the line of action and we have drawn a perpendicular towards O, and we have taken that distance. So this is how you have to find out the arm of moment, to find out the moment. So d1, d2, f1, f2. So this is what the Varignon's theorem states.